So today we are going to learn about using the data analysis tools in Excel and to focus on some of the things that we need for the 3370 class. And some of it is also useful for the 3371 class if you're going to take that. So let's start by identifying where the data analysis tool is. By default, Excel does not show that data analysis tool under the data tab. There is a way to get it started. When you open your Excel file, look on top and you'll see a place where it says file. Then scroll down to the options at the bottom. Under options, go to add-ins. When you click on add-ins, it would give you a choice of manage Excel add-ins and then click go. And make sure that you put a check mark next to the analysis tool pack. And while you're here, you might as well get the solver option because we will need it for linear programming in the future. So click those two and click OK. And then when you go into your data tab, you should be able to see data analysis and solver options. So that's the first thing to do. Summary statistics in Excel are an important way to look at data. Now I've fake created this data, so this is not a real data set. I just made it up. But say that I wanted the information about the data set, as in what is the age, the average age, what is the standard deviation of that age, and similarly, what is the minimum, maximum values, and I want the same kind of information for this height. So the way to do that, to get the descriptive statistics or summary statistics, is basically click on the data analysis tools under the data tab. And if you look, there is an option called descriptive statistics. So you click on descriptive statistics and you click OK. Now it'll ask you, what do you need this information for? Where is the data, right? Now in this case, I have two columns. One is the age and one is the height. And I want the summary statistics or the descriptive statistics for all of these things, right? So I am going to choose, notice I am picking the age and the height, and then I am choosing all the actual data. Now, age and height are labels. Make sure you pick, by default, we usually put data in columns, but occasionally you have them in rows. So be careful about that. In this case, age and height are in the first row and they are labels. So I'm gonna click the labels. You have a choice to get the output in a new worksheet, but I personally like to see my output right next to my data. So I usually will click on the output range option, click here, and all you need to do is to pick a cell, one cell, where you want the output to start. And then you click on the summary statistics. That makes sure that you get detailed summary statistics for your data. So now we click OK, and we can see that we get this information. So the mean of the age is 14.1 years in this case. The standard error is 1.28. Median is 13.5. Median is the point which divides the data into two, which means 50% of the observations are over 13.5 in age and 50% are below 13.5. The mode, or the highest frequency occurring in terms of age, is 20. The standard deviation is 4.598. Just a quick thing to talk about with standard deviation. By the central theorem, central limit theorem rule, we can say that, and I'm going to write this down because this is something that a lot of people have issues with interpreting. So about is the keyword, about 67% of the data points or the observations fall between the mean plus or minus the standard deviation, right? So about 67% of our data or of our observations in this case will fall between the mean, right? So mean minus standard deviation and mean plus standard deviation, right? So in this case, we can say that 67% of our data lies between 9.5 and 18.69. So 67% of the people who have been considered in this data set are aged between 9.5 years old and 18.69 years old, okay? This is just a quick way to describe the data when you're talking about what does this mean. In 3370, this is extremely important. And in the real world, it's important. You need to know what you're using the standard deviation for. You also have information like kurtosis, skewness, range. Range tells you that the age between the lowest and the highest is 13 points. And here you go, minimum is 7, maximum is 20, range is therefore 13. The sum, the total number, the total of all ages in this case is 282, and there are 20 people whose ages have been considered. Now you have the similar output for height. So you have 56.2 is the average height, and you have the standard error, median, mode, standard deviation, and the range, and the minimum is 44. So the shortest person in this group is 44.5 inches tall, and the tallest person is 66 inches tall, the sum and the count. So these are the basic descriptive statistics that we are going to look at. The other important thing that, so I'm going to delete this for now. Now, the next thing we need to do is to learn how to make a histogram. And for the histogram, I say that I want to get the estimate for the heights in this. So option one, and we've talked about this before. So option one is to look at, go to insert, right? And do like a simple bar graph, right? But notice that in this case, if instead of 20 observations, I had 55, 60, 60,000 observations, it would become very difficult to understand what the bar graph looks like, right? So instead, what we are going to do is learn how to make a histogram, which is a frequency distribution based graph. So there are two ways to do it. One is the default Excel method of doing it. I'm going to get this out of the way so that it doesn't interfere with us. And that is also by using the data analysis tool. So let's click on data analysis, and you'll see that histogram is an option here. You click OK, and I had done other work in this before, so I'm gonna, it'll look like this when you start. Input range. I want the information of the height, right? Now, I don't know what bins I want to create right now. So this is, like I said, the default way to do it. All I'm going to use is the label so that it recognizes that height is a label and not a data point. And then for output range, I'm just going to pick, again, E1 or something. And I want to see the visual output. So you have to make sure that you put a chart output. If you click on that, here's your histogram, right? What do the words bin mean? Bin means that number of people be at or below. So less than or equal to 44.5, less than or equal to 49.875, but greater than 44.5. Less than 55.25, but greater than 49.87. Less than 60.625, but greater than 55.25, and then more than 60.625. And so Excel picked out its own bin and range, and it gave you this histogram. Now, I don't like sometimes when all these decimals, they look pretty random. They're based on an innate formula, which you can look at later on. It depends on the range versus the number of observations in it. But what I like to do is I like to create my own bins, because then I can have my histogram being easier for me to understand. So I'm going to basically choose 45, 50, 55, 60, and then more. Or let's see, I'll do, yeah, let's just do more than 60, right? And option 1 at this point is to directly create the histogram. Option 2, and that's a frequency function, and I'll show it to you after I show you how to make the histogram, right? So if now I've chosen my bins, so I go back into the data analysis, I click on histogram, and now I'm saying, hey, guess what? I have my own bin range, right? Sorry, we're gonna choose it like this, okay? Because E11 is important. And I'm deliberately doing this because I want to show you something. And let's say that we want the output to come out on E20, which is this cell right here, okay? Click OK. Notice the bin range cannot have non-numeric data. This more that I've written here is becoming a problem. So when you are doing this yourself, instead of choosing the more, you go back and make sure that you've only chosen the bin up to this area. So I'm going to do that. I'm going to show it to you. It'll automatically add that last one for us, and you'll see in a second how. So I'm going to click OK. And notice it created the bin 45, 50, 55 and added the more option. And now I have a new histogram, which if I compare it to the other histogram, is easier to read. Okay, 45 or less, 50 or less, 55 or less, 60 or less, and more than 60, right? Now, while we are here, I also want to show you, you can change the way you want it to show up. Right here, under the chart design options, you have a variety of options that are available to you, and you can make it look as pretty as you want. You can change the look. You can play around with these visual options. So just wanted to show you all of this. Like I said, I was going to show you how to use the frequency function, and you can do it this way. So you can manually create the frequency if you wanted to, and you can use equals, FERQNCY, frequency. The data array, this is our original data. So we pick that, comma, and then this is the bins array. In this case, we do include the more because we want to make sure. And so when you enter that, hit the enter key, and you will see these numbers are the same as these numbers. But this by itself does not require you to create a histogram. So you're welcome to use whichever method you like. I personally prefer this method because I can control what the bins look like. I want to show you how to use line nest options, but I will go into the bivariate regression and line nest function in the next video. So look for the next video.